The Ender 3 version 2 mod is doing a-okay now. You can see the credit card issue has really sorted out the belt alignment so that yeah, it no longer has that rub-in there because it was rubbing against this backplate here. But anyhow, everything's going well. Not a problem from this. Not a problem from the whole printer. I did the Bowden tube upgrade where you print, it's on Thingiverse, you print these little spacers here. You stick one spacer between the tube connection here, and it goes inside of the hot ends cooling jacket there. And so you stick a piece of you measure and cut a specific length of PTFE tubing and stuff it in there with this washer here. And when you tighten down that nut, what do you call it? Bowden fitting, like that one back there. It's kind of hard to see. But yeah, you tighten it down over this and it prevents gaps from forming, which cause your filament to bundle up. So I recommend it. I tried it. There's some kits where you can get a Bowden tube cutter like this guy right here. So this guy, you slide your tube in here and cut it. Although I measured mine, what I actually did was I sat this guy in the opening. So first what I did was I stuffed this in to the hot end as far as it would go, and then I measured that length to the edge of the hot end. Second, I put this fitment in whichever spacer I chose. I stuck it in the hot end and saw how deep it sat. So I measured the thickness of the spacer. Now I use a depth gauge on my caliper here to, let's see if I can do this right. You can use this as a depth gauge from an edge to measure how deep something. So I used a depth gauge on my caliper to measure how deep it was to the spacer from the edge of the heatsink. And then I added those two together and subtracted that from the total length of tubing that sticks out to the top of the heatsink. And then I cut the tubing to length, which in my case for an Ender 3 V2 with the Mark 8 hot end was about 30 millimeters. And my spacer was somewhere about 1.5 millimeters. I don't know. Whatever the case is, it will vary. It may not actually vary for you, but not all these guides are the same. The STL files have many variations of this on Thingiverse, and I didn't see one that specifically names the Ender 3 V2. So one of these is handy for cutting the tube, but at least for the V2's hot end, I think 30 millimeters is it. But I'd still recommend you measure it for yourself. It's just a tricky one. So, but the good note is that I won't have any of those pockets forming for the hot end. So yeah, anyway, there's plenty of videos on how to actually do that, so I recommend you go there. Another thing is Aquanet hairspray just makes initial layer adhesion quite good. But say you have stringing on the initial layer adhesion, well, I cheat. Like if you have lots of threading or stringing on your print, or something is just not sticking to the build plate initially, I will just like go over it and torch it lightly, and then the strings will just shrivel up or they'll melt and then stick, and you can just press them down onto the bed and they'll stick better. So I find that a torch is good for cheating. I've also I've used it because usually the filament just shrivels like human hair when you burn it, so don't ask why I'm talking about burning human hairs, but yeah. As for what I'm printing, though, it's part of the Thingiverse 2020 dumpster fire, because really, 2020 was a dumpster fire, and I have a certain what is it, malignancy, malaise, malady, anyway, one of those words that says malignment, something that says I really hated it. It's been personally tough, and of course the whole shutdown has been a bunch of bogus, and now they find, oh hey, masks don't actually do anything, and yet we're still wearing them, so yay, not yay. Unless you're in Florida, then you really don't have to do it that much. Anyway, yeah, if you're gonna get a Fang mod like this is a 12 volt fan, and to hack it, I wired in a power resistor based on the resistor here, but I don't know if it's a great idea. And this fan doesn't always spin up very well at lower speeds. Like, for instance, if I turn the fan speed down to, say, let's see, 75. Let's see. Well, oh, how about that? It will turn. But the fact is, it's not going to blow as effectively as your typical blower fan. I just don't know of anyone who makes silent blowers. But if I had a choice, I might have gone for 4040 dual blower mods instead of a single Noctua. But really, this is quiet. This was also pretty loud when it was a blower. And the problem I have with the underneath fan is that it sticks down, and you need foot raisers, which if you're trying to vibration dampen your unit, having these plastic razors doesn't really help with anti-slide properties, and it doesn't really help with dampening. So you can't just rest it on the feet, because it puts a lot of pressure on the plate, and you can see the bottom of the unit where the the 90 millimeter Noctua fan sits. So 92, 96, I forget. But yeah, it cools the power supply, and that was loud. Oh, as for the other noisy fan that cools the power board down here, yeah, it's a 24 volt, or is it a 12 volt fan, but I think it's 24 volt. But what I did was I hooked it up to the same power that powers this fan using a 24 to 12 volt step down, and so I'm running it at half voltage. So whenever you turn down a fan's speed, then it just gets quieter just by default. Any fan gets quiet when it's not running fast. So yeah, the 24 volt fan down here is running at 12 volts. I have a manually adjustable voltage converter, step down converter in here. I think it works on the switch mode power supply principle, but yeah, so that's how I'm getting the 12 volts for this fan and for that one in there. And I don't think it would do much good for this one, because this one's variable speed. And yeah, I don't know what to tell you about that one. I just try to keep it out at 100% all the time, because I don't think it blows all that hard anyway. So yeah, here's dumpster fire. This is the big flame, and I'm printing it in cheapo red PLA. And then let's see, what am I going to use next? Oh hey, there's my girl cat, Sarah, and she is a real sweetheart. But let's see here, messy room. I'm not a YouTuber. You can get these little sampler packs of PLA, so you can try out a bunch of stuff. So these are like 200 gram rolls of PLA. This is yellow filament. The red actually kind of prints out slightly orange after it comes off the spool. This is a cheap green. And silk green. This hatch box, but it's kind of like this glossy, no, like glittery forest green PLA. It's like got glitter in it. It's kind of cool. And then I don't know, man. We got some black, some white, and some pet G, which I don't care anything about really. Marble filament's cool, but I don't like some of the exotic ones because I'd have to dial them in, and I don't have that much of them. Well, yeah. This is my other mod. I spent a lot of work on it, and it's adapted specifically for the 3D fused build plate. So the 3D fused X-axis gantry has different hole layout. Actually, this thing kit is for the Ender 3 or Ender 3 Pro, and the hole that I have drilled up here, well, there's a hole really nearby, but it doesn't match up. So let's see if I can show you. Where is it? There. You can see there's two holes back here. Let's see. Is that actually a hole? Yes, that is a hole. They're both threaded for M3, so I think actually that one might be like an M4. But the point is these. I had to drill my own hole and tap it. You just measure the offsets like this, and then you make a scratch line, then you measure the offsets and make another scratch line, and then use a center punch it, and then drill it out, and then tap it, you know. I tend to think a 1/8 inch drill bit is good for tapping an M3. But yeah, so this guy, I measured out the precise dimensions also here and here, and made this guy here to hold a dial indicator, although I don't find it actually that necessary, but it's still cool to have. Let's see, do I have that in here? Yes. So it took me like 4 or 5 versions to get this right. So basically, these cylinders here are positional supports. They keep it pressed in the middle, and then all these supports are actually tapered inward using a loft, and then they have a slight overhang, which I calibrated perfectly to hold on to the dial. Printed great on my printer. I designed it to work with like a 0.12 or a 0.16, I forget, line height. But yeah, it fits into this little groove here, so it locks in. Also, this gap and this gap, this is like, this is a 1/2 inch right here, I think. And then this is something like 5/16 or 7/16 or something weird like that. Let's see if I can get this guy in with one hand. I'm using a smartphone. Anyway, there is like no slop and no play in this. It's perfect. And so, I don't know if any of you have used a dial indicator, but the idea is in machining, let me zero that here, you tend to set it down on a surface, fixed to some reference object. And so as it moves across with the print head, if the number changes, then it means your bed is not level. So you can use the print head to sweep across and tell if the bed's level as opposed to eyeballing it. But I don't think it's practical. This took some design revision, specifically this little cutout here, because otherwise the plastic would jam into the end of this switch whenever it would slide over. So this little groove here fits over the switch. That's bad, I'm blocking out my own light. Yeah. So that, yeah. Anywho, just a few more notes on the printer. You know, I have to say it's great not using Delrin wheels anymore. I just have an OCD thing about the precision. I don't like the rolling wheels and having to adjust them and tension them and such. It's just nice. Uh, oh, getting this filament holder in though around the belts is always a bit funny, and the large spools come really close to touching the belts. Yeah, that I could do less with, for sure. But yeah, I think that concludes part whatever. Part whatever. Yes. Questions, comments. Yeah, let me know. Bye bye.